into the literature. Okay, any questions so far? This is I'm recapping. So any questions so far? Is all clear? Okay, the next question is, we know that in this, if you take the area under 0, this is point 1, if you go from right from 0 to infinity, if you take the entire area under the entire each of this curve, that is equal to sigma times t power 4. So the total emissive power of this is all meant for a black body. I will tell you in a moment what a black body is. Give an introduction what a black body is. I will give you more details together. EB will be simply equal to sigma times t power 4. And this one I told you, when you come to the computer lab and then you plot it, you just integrate it using circular rule, and also you make the calculation. If you sum up the whole thing, you will see that you will get roughly about the same. From there, actually you can find out what the value of sigma is, and also I told you sigma is, if you remember, is in 5, 6, 7 times 10 to the power minus 8 watts per meter square, will be about 4. That's unless you will. So now the question is, I want the area only this particular ring. I don't want the entire spectrum. How do I calculate that? So let me say that is a fraction of the radiation emitted between the wavelength of lambda 1 to lambda 2 is how much? How do I calculate it? What fraction is there? That is, if I want to know the UV region, no? I'm sorry. Are you able to see now? Okay. Sorry, I forgot. And we'll see later on that is what is called a Q factor. You have V factor of 0, no, you have V factor of 1. Okay, so if I want to know what is this area of what is this fraction compared to the total, that we are going to calculate. That is called what is called lambda squared fraction between two wavelengths, lambda and lambda. So this is what we are doing. This is the spectral distribution. I want to know how much is that. If you want to know between 0 and lambda, what you do is you integrate between 0 and lambda, the emissive power in that wavelength divided by 0 to infinity dB d lambda. Of course, obviously we know that for a black body radiation, denominator will be always sigma times t power 4. This is what I showed you here. So all that you require, I want to know what is this fraction divided by d. That will give me the metric or the fraction. That will be obviously a function of lambda and the temperature, because at each temperature it will have a different. At each wavelength also, I want to find out what this one is. From the observed observation, she is also evident that if you want to know the fraction of radiation to two wavelengths, ఇక్కడ నుంచి ఇక్కడ దాకా ఎంత వచ్చిందంటే ఎలా కనుక్కోవాలి, ఎలా కనుక్కుంటాం? ఇక్కడ నుంచి ఇక్కడ దాకా ఎంత సెకండ్, దానిలో ఇది తీసేస్తే. So what we do is, by doing that one, if you want between lambda 1 and lambda 2, you calculate between higher wavelengths here, out of them you just subtract it. Then you get between lambda 1 and lambda. This will give you between 0 and lambda, between two wavelengths. So you can calculate up to wavelength and beyond wavelength, also you can calculate. How much is number? Pratisari manam kuchini integrate cheyadam is impossible. And also that is that Planck's equation is a tough job to integrate that. So what has happened is there are so many engineers like you, young engineers, you know that young engineers are lazy. So someone has done the job for you. అంతేపెట్టి అన్నీ నేను బియ్యము పప్పులు కాయగూరలు అన్నీ వేసి వండుకోమంటే మన వండి తినడం కష్టం. ఎవరన్నా వండి పెడితే బాగుంటుంది కదా మనకు. సో సమ్మన్ హ్యాస్ డన్ ది కుకింగ్ అంటే హ్యాస్ డన్. సో దోస్ నంబర్స్ ఆర్ అవైలబుల్. సో ది ఇంటిగ్రేషన్ ప్లాట్ చేస్తే దిస్ హౌ ఇట్ విల్ లుక్ లైక్. ది ఫ్రాక్షన్ బిట్వీన్ lambda t and then the fraction of this one will be. So you take complete this will almost be 10 to, because I have cracked water only up to 20,000. If you were to take it to infinity, it is 10 to 1. And initially it will be pretty close to 0, then it comes. So then gradually it quantizes. So what is the nature of this curve? Tell you, then I want physically the numbers. If you want to know any particular thing, lambda t will be, let this just work. That number will be bit. The accuracy you get is as good as the thickness of your pencil. So if you want exactly the numbers, I will show you what those numbers is like. This is what it is. If the lambda is equal to 200, the fraction is almost 0. That is, that you can see here, starts rising, it happens. So you can see the initial is 0, then keeps on going up and up and up. So it keeps on, you can see it keeps on going up. Then you have got right up to 100,000 objects. Okay, we'll be using that in next few minutes. I'll project this one back and I ask you to pick up that number. Okay? So that gives you the fraction. Now, so the black body is not realized in reality. That's what I mentioned to you last year, in last class. Then what happens is, why do you need a black body? So normally we say that we have a car efficiency, say about 40%. What is that 40% of what? If it is ideally it is something, if I am getting 100, I am not getting 100, it's 100. Like in a class, for example, a brilliant student who gets about 100 out of 100, the other student is getting only 60 out of it. So we say that compared to that student, you are getting 60%. Similarly, we need some kind of a comparison where we can evaluate a real object compared to an ideal object. So black body is an ideal object. When it is at high temperature, it limited maximum amount of power. And also it has got a property where it is at a lower temperature, it will absorb maximum amount of power. So that is the nature of a black body. But most of the real surfaces are not exactly black bodies. There is some of the black bodies are, they tend to pretty close to, but not. Let me tell you one more thing. Black body is not necessarily black in color. To give you an example, do you know what is the emissivity of white paper? What is your guess? It is actually pretty close to 0.9. If you go to, of course, has anyone seen snow? Like Himalayas and snow, Kashmir, or you would have seen in the television.